easy one. Leetcode 1281, subtract the product and sum of digits of an integer. So here we have a digit 234, right? So the idea is that if we can separate the digits individually, so it's 2 and 3 and 4, we multiply them all together, right? So 2 times 3 times 4, that gives you 24. And at the same time, you can sum them up. So 2 plus 3 plus 4, that is 9. Once you got those two numbers, then you just have to subtract from each other. So 24 minus 9 equals to 15. See? So the only trick here is that there's a technique for actually extracting the individual numbers, and it's basically repeatedly taking the remainder division between this and 10, which gives you a number that is from 0 to 9, right? When you do a mod of 10, that will always give you a number less than 10, right? And then at the same time do a division with truncation, integer division by 10. That will actually remove a number, right? So initially you have 234, then you reduce the number to 23, and then later to 2, and so on, right? So that's how you extract the numbers. So that is really the trick here. So let's just do that. Let's hopefully we can do this one in like maybe a couple of minutes, okay? So here we go. So we have the number here, right? So we do a while loop here, right? So while n is greater than equals to greater than 0, because eventually when we keep dividing the number, it'll become a 0, and that's when we stop. Since we don't really need the n, we can just reuse this one, and otherwise we can assign the n to a temporary variable. Okay, so then we also need two variables, one for sum, which starts at 0, right? And then a product, right? Product, which should start at 1, because when you multiply by 0, you're always gonna get 0. So for multiplication, you start at 1. For summation, you start at 0. So here, what you need to do is we get a digit, right? So let digit is equals to n, right? As we said before, we take the remainder, which gives you a digit, right? So no matter how big the number is, a digit will be from 0 to 9. So we're extracting the last digit, right? So from 234, if we do a mod 10, we get 4. Okay, so now we have the digit, right? And now we can actually add them to the sum, right? So sum is equals to itself plus the digit. So we can do this plus equals digit. And then for product, we'll multiply the product by the digit. Okay, and let's not forget to shrink n, right, by dividing itself by 10. So you can say n divided by 10, okay, as so. But again, this is a JavaScript thing where it's not integer division, so you have to do a math.floor. I had this problem earlier with the other problem with the binary search. I have to invoke this function. If you come from Java, you don't need this floor function because it is an integer division. Okay, so this in effect truncates the last number, so the next iteration it'll be 23, right? And this is pretty much it, right? So by the end of this loop, the sum will have the sum of all the digits, and then the product will have the product of all the digits, right? So you just have to return the product minus the sum. And let's just run this. Accept it. All right. So once again, as you can see, if you do this in your head, you can see that each iteration, this number actually gets reduced, right? So from initially from 234, it becomes 23, and then from 23 becomes 2, right? And when it's 2, this is still true, and so 2 is the last iteration. And once you divide 2 by 10, and you take the floor, which means you truncate down, right, you're gonna get 0, and that's when this terminates. All right, thank you very much. This was an easy one. Bye for now. Oh yes, actually, as I was saying, going forward, I'm going to talk about the complexity of this issue, this problem, right? So basically, this would be, the complexity would be order of a number of digits, right? Not the number itself, but the how many number of digits. That's the number of iterations we go through this loop. And in terms of space complexity is constant because we are not actually allocating any space. So it's going to be O of length of digits, right? Of n, right? I don't know, whatever you can do. You can convert to a string or something, right? So it's proportional to n, but not proportional to n, but proportional to the somehow to the n, but not directly. And then the space complexity will be constant, right? So that's it. Thank you.